Mixing is one of the core steps in many process industries. Mixing can be done either of solid, liquid or even gas. Hello everyone, I am Majid and I am doing MTech from Electrical Engineering, Zakir Hussain College of Engineering Technology, Aligarh Muslim University. Today we are going to see how a mixing unit plant can be automated. First of all, I would like to tell that a project has been supported by NPIU under TechCube second program, and it is being also supported by Ministry of Human Resource Development and the World Bank. These are the project overviews. So in the next 10 minutes, we will be looking into details like real world problem description, the automation concept, the program logic controller along with the visualization of HMI SCADA and the further step for this project. When we used to do the mixing on a small scale, we can do it manually. Like for example, we can take that if we are going to mix some ingredient in a household work, we can do it manually. But if we are going to take a concept or if we are going to take an example of a large scale industry, the mixing by manually is not easy because it cannot be reliable. Along with the reliability, the efficiency of the mixing will not be so that good. Along with the two qualities like efficiency and reliability, the product obtained will also not be guaranteed. Here, we can see that the main problem is the control sequence of a mixing unit in which two substances are mixed into one container via conveyor belt. The process should be automated so that the mixing is a combination of 50% substance 1 and 50% substance 2. It is to be noted that the main and most important thing in the mixing is the proportion. How much concentration of which substance is to be added by which proportion. Second is the no manpower is required to achieve this task. And the most important thing is the system should be flexible and can be used for any concentration mix. Now, I'll be going through the main components of the automation concept. In the main component of automation, this is the whole schematic diagram of the mixing unit. In the schematic diagram of a mixing unit, there are the two substances in which we can call it a raw material. These raw materials are filled in container 1 and container 2 as we can see. These raw materials are dropped down on the conveyor belts. These conveyor belts are being driven by the motors. And as we can see that all these motors are hardwired by a central intelligence called as programmable logical control PLC. As we can see from the figure that this PLC is being connected by HMI screen. What really a HMI screen is? Well, HMI screen is basically where a whole program is being visualized. And as we can see that this PLC is connected or the communication between the PLC and HMI is done with the help of Profinet. Now, my whole project is being divided into two different parts. The first part will contain the Siemens TIA professional software in which I will do. The first one will be I'll create the tags. The second one will be I'll create the logics. I'll draw the block diagrams for different things and different steps. The third one will be the testing along with the downloaded to the PLC. My second part will contain a different software that will Siemens VCC Flexible. In this also I'll do some steps like the first one will be create the connection in tags. The second one will be create the screens. The third one will be testing and then the downloading it to HMI. As again in this slide we can see that the HMI screen and the PLC is being linked by a Profinet. Now let's move on to software. As we can see, this is a TIA software developed by Siemens. In this, the CPU we use is CPU 314 to PNDP. As we can see in the PLC, this is the power supply unit, this is the CPU. As I just told, this is CPU 314C to PNDP. This is the input output cards and this is the unmanaged switch. Now, as we go to the program, I'll first show you the program blocks. As we can see from the program, this is my main program. First of all, I would like to tell what I have really done in this whole program. In this whole program, I have developed 8 networks. The first one will be for initialization, the second one will be for HMI call, the third one will be for automatic mode, the fourth one will be for manual mode indicator light along with the enable belt 1 and 2. Then the 6, 7, 8 network will be for the belt 1 deceleration, belt 2 deceleration and belt 3 deceleration. Now, I'll give you a brief explanation what I have really done in my whole TIA software. First of all, I have initialized so that after every single process, my whole process will come to a reset or to an initial state. The second one will be HMI call. In HMI call, I call it to the HMI screen, or you can say the SCADA or HMI screen. The third one will be the automatic mode. In this, I have made the conveyor belt to be moved automatically. The fourth one will be I enable a manual mode. If we do not need to move a conveyor belt automatically, we can do it manually by just clicking the buttons. The fifth one will be I have enabled the belt first and second, in which the raw material has to be filled to the mixture. The sixth one will be the belt one with deceleration time of 3 seconds, along with its indicating sensor light H2. The second one will be the deceleration time third of 3 seconds as well, with indicator light H3. And last will be the belt 3 with the deceleration time 5 seconds of the indicator belts. These are by movement calls. In the movement calls, what I have done really is I have just called it HMI operation to the belt 1 and 2, 3 to the main block. Now, let me download it to the PLC. It's completed. So, let's now jump to a next software that's called VCC Flexible. It is also being developed by Siemens. Well, this is my Siemens screen. In this, I have really developed two screens. The first one will be the start screen, along with the second screen in which my whole process is being done. In this software also, I have created some text to be connected to the main screens. In the working screen, we have created a demo, so we can just transfer it to a HMI screen. As we can see here, the HMI screen is being developed. Completed. So, this is basically my HMI screen. It is a touch panel TV 177B. As I have transferred my whole program from PLC to the screen, this is my initialization button. I have initialized my whole plant. The first part will be the automatic button. With the help of this automatic button, my conveyor belt will move automatically and I don't have any control on it. So let's move on or do more creative things in this. If I want to say that my container or the mixing container is full, then we can see that after 3 seconds my conveyor belt, which is being dropping the raw material in the conditioned mixture content, this will be stopped. And now I can say that the mixing content container is full. I want to clear it. I just have to press this button. As we can see that my belt 3 will be moved, and this belt 3 will clear all the mixing content container to the storage tank. If we don't want to do it automatically, I can say that I want to do it manually. Then I have to reset my whole program with the same initialization button. It is being stopped with this button. I have initialized. Now there is a manual mode. If I touch on this mode, my 3 belt will move manually. Now I have the control on the 3 belts. If I want to move belt 1, I just have to press belt 1 button. My belt 1 is moving. I just have to press the belt 2nd button. The belt 2nd conveyor belt is moving. And in the same case, the 3rd belt is moving. So this is basically my whole program which is being implemented on the screen. Now, let us quickly jump what really we have done. The further step for this project in future. The first point will be remote access of monitoring and control. As we all know that the Industry 4.0 has created a boom in the industries by creating a cloud networking. Through cloud networking, we can sit at any place far distant from the main plant and we can control it from anywhere. The second part, which is also being held by the cloud network, is cyber security for above step. The third one will be live model for the mixing unit. The fourth is the development of wireless industrial network. And the last point will be advanced power quality integration over Profibus. In the end, I would like to thank Electrical Engineering Department, Aligarh Muslim University, for establishing this state-of-art industrial automation and also organizing this training. I would also like to thank ZMS Technology Germany for conducting this training. Thank you.